Hi guys, my name is Melissa and today we're going to be talking about fractions. And so before we talk about fractions and solve questions, we're going to go over the basics of fractions. And so I think we might not go over too much detail for fraction basics because we kind of assume that you guys remember, but I'm pretty sure that for some of you guys it still might be a little confusing. And if we have a really sturdy and solid base for fractions, later on it becomes really easy to add, multiply, divide, and all that. And so we're just gonna do a quick review of fractions. And so for fraction, it looks like this. So A, the number at the top, is called numerator, and the number at the bottom is called denominator. And so a fraction is basically when we divide something by something. And so A is the number that's being divided, and B is the number that is dividing. So for example, if we're going to divide 42 by 8, A is 42 and B is going to be 8. And also, we're gonna go over concepts of where we have to compare two fractions. And so if we have the same, for example, if we have A, C, and B is the denominator. So this is a scenario where the denominator is the same. So it's same denominator. But then the numerator is different. And in this case, A is greater than C. Then that means that this fraction is bigger. So when the denominator is the same, the fraction with the larger numerator, so the larger top number, is going to be larger. And that is because we're dividing a larger amount by the same amount. So for example, let's think of it as this. So since the numerator, or the number in the top, is the number that's being divided, let's say we have 20 apples and 10 apples. And B, or the denominator, is the number that is dividing. So we're dividing by B. We're dividing by the denominator. So let's say we're dividing by 2. So we're dividing by 2 because let's say we have 20 candies and 10 candies. And we want to give 2 candies per person. Then since we are dividing by 2, we know that we can give 10 people candies because we're giving 2 candies per person, and so we can give candies to 10 people. But on the other hand, we can only give candies to 5 people because we're dividing by 2. And so this is smaller. So basically for the result, when the numerator is bigger and the denominator is the same, then the fraction with the larger numerator is greater. But what happens if it's the opposite? What happens when the numerator, so the number in the top, is the same, but the denominator is different? Well, let's say that B is greater than D. Now in this case, the fraction with the smaller denominator is going to be larger. So D is the smaller denominator, so the fraction itself, A over D, is going to be larger. So it's the opposite with the example above. When the numerator is different and the denominator is the same, larger numerator is larger. But when the denominator is different and numerator is the same, the smaller denominator is larger. And so again, let's think of it using the candy example. So we have 20 candies, but since the numerator or the number we're dividing is the same, let's say we both have 20 candies. But then I want to give it to 5 people, and I want to give it to one person. I want to give it to 2 people. And so this is the number that we're dividing by. So these are the denominators. 20 divided by 5 is going to be 4. So each person is going to receive 4 candies each. But when you're only giving it to 2 people, each person is going to receive 10 candies each. So when the denominator is smaller, you divide by less, so the result becomes larger. We have that, and we're also going to do a basic review for addition as well, and subtraction. And so when we have the same denominator, let's say we have AC, and the denominator is both D. Then we have the same denominator. We have the same denominator, D. Then since the denominators are the same, the result of A over D plus C over D is going to be A plus C over D. Now it's the same for subtraction. If the denominator is the same, it's just going to be the numerator that changes, and the denominator is going to be that common denominator. But of course, there are times where the denominator is different, both for addition and subtraction. Then we have to find a common denominator. Usually we multiply those two, like DC. And then since we have to multiply C to this to get DC, we also multiply C to the numerator. Also, same thing, we had to multiply D here, so we also multiplied D there. Same thing for subtraction. Same thing for subtraction. It's going to be AC minus BD. And so yeah, those are basically what we need to keep in mind when we do fractions. And so today we're going to learn about fractions and adding them. And we're also going to talk a little bit about using number lines to represent fractions. And so let's get right into it. And so a fraction is a number, and it's a way to write division. So for example, if we divide 5 by 7, we can write that as 5 over 7, or call it 5/7. And so if we have 5 over 7, the number at the top is called a numerator. And that is the number that's being divided. And the number in the bottom is called the denominator. And that is the number that we're dividing by. And so since we're dividing 5 by 7, the numerator, which is the number that's being divided, is going to be 5. And 7, which we're dividing by, is going to be the denominator. And also we can represent fractions in a number line by splitting the line between 0 and 1 into 7 equal pieces. Now we're splitting it into 7 equal pieces because we split it into how many spaces we need based on the denominator. And so we're splitting it into 7 equal pieces because our denominator is 7. And so that means that each piece has a length of 1/7. And so if we go 5 spaces or 5 times, then we're going to reach a point where we get to 5/7. Now we're going to label the number marked on each number line below for practice. And so since it's from 0 to 1 and it's split 5 times, we know that each space is worth 1/5. And then since each is worth 1/5 and then our box is at the 3rd line, we know that it must be 3/5. Now for question 2, we have 1, 2, 3, 4, 5, 6, 7, 8 lines. So 8 spaces. So each space or each line is going to be 1/8. And since we're on the 3rd, it's going to be 3/8. And then, sorry. So it's going to be 3/8. And then over here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So each is worth 1/9. And so since we're on the 5th, it's going to be 5/9 or 5/9. And for question number 4, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So each is going to be worth 1/11. And currently we're on the 8th. So we're going to be 8/11 or 8/11. And here we only have 4 spaces, so each is going to be worth 1/4. And here we have 6 spaces, and we're on the 5th one, so it's going to be 5/6. Now we're going to move on to the next page. And so some fractions equal whole numbers. And so it says write 65/5 as a whole number. Since fractions are a way of dividing, this is basically the same thing as dividing 65 by 5, and that's going to give us 13. And so 65/5 can be written as 13. Now we're going to write each fraction below as a whole number. And so 48/8 is basically 48 divided by 8. And that would be 6. Now 91 divided by 7 can be written as 13. For 55/11, 55 divided by 11 is 5, because 11 times 5 is 55. And then we have 75/15. So that's going to be 5, since 5 times 15 gives us 75. And so we're using the division that we learned in the previous video. And dividing 156 by 3, we get 32. And 52 divided by 52, which is dividing it by itself, so it's going to give us 1. Now it says, for each equation below, fill in the numerator so that the equation is true. Now, so we have a number and we divided it by 7 to give us 2. And so that means that 7 times 2 is going to be this number. So this number is going to be 14. Now to double check, 14 divided by 7 is going to be 2. And so again, 3 times 12 is going to be that number. So 36 divided by 3 for confirmation gives us 12. Now to find the number that we're dividing, we want to multiply our answer and what we're dividing by. So 3 times 17 is going to give us 51. And so 51 divided by 3 is 17. For 16, we're doing 5 times 1, so it's 5. And so 5 divided by 5, dividing by itself, is going to give us 1. Now 13 times 11 is going to give us 143. And so we know that 143 divided by 13 gives us 11. And then for 18, we're multiplying 15 and 7. So that's going to give us 105. And so that tells us that 105 divided by 15 equals 7. Now it says label 27 over 4 on the number line below with the mixed number. Now, so 27 over 4 is between 24 over 4 and 28 over 4. And so 24 over 4 is 6 and 28 over 4 is 8. 28 over 4 is 7. So 27 over 4 is between 6 and 7. And in between 6 and 7, we have 4 spaces, and each is worth 1/4. And so 6 is 24 over 4. So we need to go 3/4 more, so we're going to go 3 more steps. And this is where 27 over 4 is going to be at. And 27 over 4, we can consider this as 24 over 4 plus 3 over 4. So that's going to be 6 plus 3 over 4. So we write it as 6 and 3/4. Now we're going to do the same thing for our practice problems. So it says label 16 over 3 on the number line below as a mixed number. So 5 is 15 over 3 and 6 is 18 over 3. And so 16 over 3 is going to be somewhere in between. And we have 3 spaces, so each space is going to be worth 1/3. And so 16 over 3 is going to be right here. And we can write that as 5 and 1/3. And so in this case, we're going to use number lines. And so to label a fraction on a number line, just like what we did, we want to first compare it to 2 whole numbers. So since we have at least 3 whole numbers in the number line, we want to place it in between 2 whole numbers. So for example, if we're given a fraction, then we want to see a whole number that the fraction is greater than, but we also want to see a whole number. We want to see a whole number that's greater than the fraction, but we also want to see a whole number that's smaller than the fraction, so we can kind of estimate where the fraction lies in between those 2 numbers. And also, an easy way to do this is we can convert the whole number into a fraction, because we can just multiply the whole number by the denominator and put that in the numerator. And so that can make it easy to compare the fraction with the whole numbers. So for 55 over 8, 7 is 56 over 8, and 6 is 48 over 8. And so 55 over 8 is going to be somewhere really close to 7. And we have 8 spaces in between, so each space or each line is going to be worth 1/8. And so since 55 over 8 is 1/8 less than 56 over 8, it's going to be over here. And then we can write this as 6 and 7 over 8. Next, we're labeling 39 over 4. And so 8 is 32 over 4, and 9 is 36 over 4. So 39 over 4 is greater than 9. And since we know that there's 4 spaces in between 8 and 9, we know that each line or each space is worth 1/4. And so we have to go 3 spaces from 36 over 4 or from 9. So this is going to be where we have 39 over 4. And we can write that as 9 and 3/4. And then for problem 22, we have 34 over 5. And 7 is 35 over 5. And based on the distance from 7 to 8, we know that each space is worth 1/5. And so since 34 over 5 is 1/5 less than 35 over 5, this is going to be 34 over 5. And then, so we have fractions that represent the same number are equal and are called equivalent fractions. And so, for example, it says, write 5 fractions that are equivalent to 12 over 30. And so it says we can multiply both the numerator and denominator by the same number. And so multiply it by 2, by 3, whatever number you want. If you multiply both numerators and denominators by the same number, it's going to still give you the same fraction. So we can basically find an infinite number of fractions that are equivalent to a given fraction, because not only can we simplify it by dividing the numerator and denominator with the same number, but we can also multiply the same number to the numerator and the denominator, and that would just keep making equivalent fractions. Now when we multiply, though, we need to remember that we're multiplying, and so the numerator and denominator are going to become multiples. So now we're increasing it, and it's not going to be the simplest form. So actually it's going to go farther away from the simplest form. But if we want to get to the simplest form, we always need to divide. But when we multiply, it's just a way of getting multiple equivalent expressions. So for example, when we multiply 2 to both the numerator and denominator, the ratio itself doesn't change. That is why we can multiply any number, but as long as we multiply the same number to the numerator and same number to the denominator, the ratio remains the same, and that is why it's possible. And that's why even when we multiply, if we multiply the same number to the top and bottom, then we get equivalent expressions. And so regardless of whether we multiply 2 to the numerator, 2 to the denominator, or 18 to the numerator and denominator, it's still going to be equivalent expressions. But then the problem happens when we only multiply to the numerator, only multiply to the denominator, or we multiply different things. If that's going to happen, that's going to disrupt the ratio between the numerator and the denominator, and that is where we have issues. And when we don't keep multiplying the same amount to both the numerator and denominator, the ratio will be ruined, which in turn causes the fraction to become a different fraction. and now once the fraction becomes a different one, it is no longer equivalent with the original fraction. So just be careful to multiply to everything at all times. So multiplied by 2, 24 over 6, multiplied by 3, 36 over 90. It's going to give you the same thing because when we simplify, it's eventually going to give us 2 over 5 in total. So everything is going to be simplified into 2 over 5. And so there are many other fractions equivalent to 12 over 30. And so it says, for each equation below, fill in the blank numerator or denominator so that the equation is true. So to get from 9 to 27, we multiplied 3. So we're going to do the same thing for the numerator, and it became 21. From 12 to get to 2, we divided by 6. So we're going to divide 42 by 6, and that's going to give us 7. And then to get from 40 to 10, we divide it by 4. So we're going to divide 56 by 4, and so that will give us 14. And to get from 6 to 72, we multiplied by 12. So we're going to multiply by 12. Gives us 60. To get from 28 to 2, we divide it by 14. So we're going to also divide by 14. And 42 divided by 14 is going to give us 3. Now to get to 9, we multiplied by 3. So we're going to multiply 2 by 3, gives us 6. Then we multiplied by 3 again, so we get 27. Then to get from 30 to 20, we multiplied 20 over 30 to 30, right? And that gave us 20. And so we're also going to multiply 20 over 30, and that is going to give us 16. Now we're going to move on to the next page. And so now it says, compare 3/8 to 15 over 32. And so to get from 8 to 32, we multiplied 4. To get from 3 to 12, we also multiplied 4. So these two fractions are basically equivalent. But then, so that was 12. But then in the question, it asks, compare it to 15 over 32. And so since we know that 3/8 in terms of the denominator 32 is 12 over 32, that is less than 15 over 32. So we can say that 3/8 is less than 15 over 32. And so we want to compare by matching the denominator. But in this case, the denominator are both 5. So the one with the greater numerator is going to be larger. Now in this case, the denominators are different. So we're going to multiply both of them because it's hard to get from one to another when it's like 8 and 9. It's not like getting from 5 to 15. 8 and 9 are completely different. So we're now just going to multiply these two together and change both of them. So both are going to have denominators of 72. And to get from 8 to 72, we had to multiply 9. So we're going to multiply 3 to 9. So that's going to give us 27. Now to get from 9 to 72, we multiply 8. So 8 times 3 is 24. And so 27 is greater. And so 3/8 is greater than 3/9. Then to get from 4 to 2, well, not to get from 4 to 2. So we're going to change the denominator to 8. And so we multiplied 2, so we're also going to multiply 2. 6 is greater than 5, so 3/4 is greater than 5/8. Now we're going to change the 5 to a 15. We multiplied 3, so we're also going to multiply 3 to the numerator. And 11 is greater than 9, so 11 over 15 is greater than 3 over 5. And we're going to change the 9 to 27 by multiplying 3. They're the same, so these two are equivalent fractions. And then in this case, we can compare the numerators. And so 5 over 18 is basically 15 over 24. And when the numerator is bigger, when the numerator is bigger, that means that the fraction is bigger. But then when the denominator is bigger, that means that the fraction is smaller. So the fraction with the smaller denominator is going to be larger when the numerator is the same. So 15 over 23 is going to be greater. And that was also another way to solve problem 30. When the numerator is the same, the fraction with the smaller denominator is going to be larger. Then we can do 55 by multiplying 5. So 7 times 5 is 35. 40 is greater, and it's the numerator, so 40 over 55 is going to be greater. For 36, we can set up the denominator as 45, so we multiplied 15. We're also going to multiply 15 to the numerator, and we get 30. 32 is still greater. And then for this, we're going to match the numerator. So we're going to multiply 9 to the numerator so that we get 45. And the denominator is going to be 9 times 7, which is 63. So 63 is the smaller denominator, so that's going to be the larger fraction. Then we're going to match the denominator to 39 by multiplying 3. So 8 times 3 is 24, but 25 is still greater. Now we're adding fractions. And so it says, what is 3 over 7 plus 2 over 7? Since our denominator is the same, we can just add the numerator. So it's going to be 5 over 7. So in this case, the denominator is the same, so we're doing 4 plus 1 over 8, and that is going to be 5 over 8. And one way to do this is we have 4 over 8, and then we add 1/8, and that's going to bring us to 5/8. In this case, our denominator is the same, so it's going to be 4 over 5. Again, we start at 2 over 5, and since we know that one space is worth 1 over 5, to add 2 over 5, we go 2 spaces, and it's going to bring us to 4 over 5. Same denominator, so just add the numerator to get 7 over 9. Again, we start at 9 over 2, and one space is worth 1 over 9, so we're going to go 5 spaces. And that's going to bring us to 7 over 9. Same denominator, so just add the numerator, and that gives us 1. So again, we start here. Each space is worth 1 over 6, so we go 5 times to add 5 over 6, and that brings us to 1. Same denominator, add the numerator together, so it's going to be 7 over 11. So we start at 4 over 11, and we know that each space is worth 1 over 11, so we're going to go 3 spaces, and that brings us to 7 over 11. Now for problem 44, same denominator, so we just add the numerator together, so it's going to be 9 over 10. So we have 3 over 10, and we know that one space is worth 1 over 10, so we're going to go 6 spaces, and that brings us to 9 over 10. And so now without the number line, same denominator, just add the numerator together. Same denominator, add the numerator. Same denominator, add the numerator. Same denominator, 8 plus 4 is 12. Same denominator, 2 plus 3 is 5. Same denominator, 7 plus 1 is 8. Same denominator, that's going to be 1. And same denominator, just add 2 plus 4 to get 6. And then it says write in simplest form. So we can simplify. So if we have 12 over 15, we can divide both by 3. So we can get 4 over 5. And then for 8 over 12, we can divide both by 4. So we can get 2 over 3. And then for 6 over 9, we can divide both by 3, so we can get 2 over 3. Now it says, on the morning of April 5th, 1/10 inches of rain fell on Beast Island. Later that day, another 7/10 inch of rain fell. How many inches of rain fell on that day? So we're adding 1/10 and 7/10. That's going to give us 8/10, and when we simplify, we can divide both by 2, and that gives us 4 over 5. So we have 4 over 5, or 4/5 inch. Our last problem says, Allie mixes 3/8 cup of granola with 1/8 cup of chocolate bits and 3/8 cup of mixed nuts to make trail mix for her hiking trip. And so she has 3/8 plus 1/8 plus 3/8, and all the denominator is 8, so we're just going to add the numerator, so it's going to be 3 plus 3 plus 1, and that is going to give us 7 over 8, so it's going to be 7 over 8 cups. And that is it for our class today, and I'll see you all in the next video.